Hunter Hellinger.
I'm Kiana Berrigan.
I'm Colby Myers.
And we are
Global Woofing.
We wanted to join the Sustainable Doghouse competition as a fun, hands-on activity during the pandemic year of virtual learning. Ultimately, we wanted our design to be an upgraded, sustainable version of the standard doghouse. First, we used recycled materials in the structure. Most notably, most of the wood that was in the various aspects of the structure had been my childhood bunk bed that I had used for nearly 20 years. And when I first got it, it was a crib to college set, and I guess it's crib to college to doghouse.
We also incorporated active fenestration when designing the roof and porch of the doghouse, which is the practice of blocking light strategically to effectively control the climate within a space. Overall, our design was created by improving upon the methods and materials used within the doghouse, which includes processes like recycling, fenestration, as well as other methods such as water collection and draining.
The creative features of our doghouse include that it's practical for all sizes of dogs. It has both an indoor and outdoor area for the dog. It also has a water collection system with gutter and storage areas. It has a situational roof that lets you change the color to best fit the climate. There's a black side that absorbs heat and doubles insulation as it sits, and there's also a white side that acts as a shaded porch and reflects heat. There's also a trellis along the porch, which can act as a future place to add vine plants.
We had to consider the sustainability of the materials used within the structure as well as their effects on the environment during and after the build. Specifically, we used fully recycled materials from various sources, including some of the following. Hunter's childhood crib to college bed frame. We found scrap materials from construction sites that we had gotten approval to go and obtain some. We found PVC pipes in an empty parking lot. We obtained 2 wood pallets from a Home Depot dumpster. And then we also used non-VOC oops paints from Home Depot that were mistakenly mixed and would have just been thrown away if we hadn't bought them. We also had to consider what green features we could add to our design to ensure sustainability once it was built. These features include the climate-controlled adjustable roof, as well as the gutter system that allows rainwater collection and storage.
The structure was a product of the bed frame and organization. More specifically, we considered the most effective way to design the roof that would allow it to be easily maneuvered and structurally capable of providing shelter and support. Stability of the final structure that is also capable of withstanding large dogs and their shifting weight. The entire build is made of wood screws, PVC pipes, and metal fittings. Specifically, the feet are made of 2x4s from the wood pallets and interface with the ground, lifting the structure off the ground nearly 4 inches. The frame is made of thick pieces of wood from the bed to support the base and are connected to the feet. The base is where the mattress previously sat. This wood acts as a smooth surface for the floor. The pillars are drilled into the frame and feet for maximum stability and are what keeps the house upright. The walls and roof connect to the pillars and add stability and protection from the outside, primarily made of sheets of wood.
We also needed to consider the dog's level of comfort when designing the structure and choosing the materials. Specifically, there's the climate control feature on the rooftop that allows the dog to be comfortable in both warm and cool environments. The floor is angled towards the center where there are slits for water to escape rather than collecting. The wood was sanded for the dog's safety, and there was also sealant applied on the wood for water resistance and mold prevention. We used non-VOC paints. We also have windows on the bottom and top that add ventilation. We also have a shaded or unshaded porch, and the doghouse is lifted off the ground to keep the floor dry.
We began this process by brainstorming a realistic design that is practical and efficient. We also had to consider the materials we had to build around and what we were given to make the structure. We considered using cardboard as insulation, but in wet conditions this would create a mess. We considered making the build a wacky shape with a living roof, but the building process seemed too difficult to produce, and effectively over a long period of time the implications of wood mixed with soil do not mesh well. What we settled on was a conventional-looking house inspired by southern porches that blocked the sun while still feeling airy. This design was complemented by the knowledge we gained in EVE 312, discussing how temperatures can vary based on external colors and temperatures. After choosing this design, we went to the software where we had begun a rough draft and improved from there. We decided the base had to be well supported, as it would hold up the uneven weight distribution, and also worked out the kinks of the dual roof system and how it would sit over the porch. We also designed it to be weather resilient and to have a place for hot air to rise out of the structure after the design was finalized. We built the structure nearly exactly how we designed it, with only minor practicality changes.
This was our first hands-on engineering project, especially the first time that we designed and constructed a sustainable building. And so ultimately we hope to learn how to complete this type of project as a team, working with our individual strengths and weaknesses and learning how to apply those in this kind of setting.
Throughout the entire process, we learned about the design materials and sustainable features, but faced many roadblocks. For example, it was a challenge to figure out how to build up from the base in actual practice. Also, screws would shear off, and screws were too long and too short. The hinges have limitations in their range of motion, which made them more difficult to work with. Additionally, we initially struggled using SketchUp software, as it was our first experience with it. For example, the software is relatively straightforward, but because it was our first time using it, there are several awkward joints and connections in the design that we struggled to recreate. It is also difficult to manipulate pipes. Finally, surfaces continued to disappear in SketchUp when using it, and some surfaces would not disappear.
With these mistakes, we worked to find the simplest solutions. For example, we drilled the holes first to prevent the screws from shearing anymore. To build from the base, we added supports and pillars that the walls would then be connected to. And then with trial and error, we were able to successfully implement the hinges with no gapping.
Next time, we would start by obtaining the right tools and materials for the job by making a complete quantitative list of everything we would need. For example, if we had known the specific types and amounts of screws, the different kinds of saws that would be required, as well as knowing the correct size of hinges, we would have had saved a lot of time, money, and energy. Additionally, we would also learn how to use the design software beforehand to improve the efficiency of the design process.